A disc brake system is a type of braking mechanism that uses calipers to squeeze pairs of pads against a disc, or rotor, to create friction, thereby decelerating or stopping the rotation of the vehicle's wheels. Over the years, disc brakes have become the standard for most vehicles, especially on the front wheels, due to their superior performance and heat dissipation compared to drum brakes. Here's a step-by-step explanation of how a car disc brake system works. Basic components. Brake disc. Rotor. A flat, round piece of metal that rotates with the wheel. The braking action happens when the brake pads squeeze this disc. Brake pads. These are the friction components. When pressed against the rotating disc, they create the necessary friction to slow down or stop the wheel. Caliper. This houses the brake pads and straddles the rotor. It also contains one or more hydraulic pistons. Brake fluid. A hydraulic fluid that transmits the force from the brake pedal to the brake calipers. Brake lines. Tubes that carry brake fluid from the master cylinder to the brake calipers. Master cylinder. A device that produces hydraulic pressure when the brake pedal is pressed. Operation. Brake pedal application. When the driver presses the brake pedal, it actuates the master cylinder. Hydraulic pressure. The master cylinder pressurizes the brake fluid, which then travels through the brake lines. Caliper activation. The hydraulic pressure reaches the brake calipers, causing the pistons inside the calipers to move. Brake pad engagement. As the pistons move, they push the brake pads towards the rotor. This results in the brake pads squeezing the rotating brake disc on both sides. Friction and deceleration. The contact between the brake pads and the rotor creates friction. This friction slows down or stops the rotation of the wheel. The heat generated from this friction is dissipated into the atmosphere, as the rotor is exposed to air. Release. When the brake pedal is released, hydraulic pressure decreases. Springs or seals in the caliper retract the pistons slightly, pulling the brake pads away from the rotor, which allows the wheel to rotate freely again. Advantages. Heat dissipation. Disc brakes dissipate heat more effectively than drum brakes due to their exposed design. This reduces the risk of brake fade under heavy usage. Performance. Generally, they offer better stopping performance compared to drum brakes. Maintenance. Easier to inspect and often simpler to service since the components are more accessible. Resistance to water. They tend to perform better in wet conditions since water can be easily slung off the rotor and any water between the rotor and pad will be heated and turned to steam. Types of disc brakes. There are variations in disc brake designs. Vented rotors. These have a space between the two braking surfaces, allowing for better heat dissipation. Slotted rotors feature slots on the braking surface to help move away brake dust and gases for improved performance. Drilled rotors have holes drilled through them to aid in heat dissipation and water removal, though they can be prone to cracking under severe conditions. Solid rotors are a single solid disc and are generally used in lighter-duty applications. In summary, a car disc brake system uses hydraulic pressure to squeeze brake pads against a rotating disc, producing friction that slows or stops the vehicle. The exposed nature of the rotor allows for effective heat dissipation, ensuring consistent performance.